Today I'm going to try to further explain or help you understand the difference between correlation and causation. A lot of people get these mixed up. Just because something is related doesn't mean it's going to cause the second variable. So in correlation, a linear correlation, just because it has a strong positive or a strong negative association doesn't mean it's going to cause something to happen. So it's very easy to understand between the two, because correlation means something is related, causation means something is the cause. So, and when you look at correlation, you're going to look at the positive or the negative associations, and just because it's negative doesn't mean it's less likely to happen or whatever. So how we're going to see the correlation is, I think the best way to understand between the two is through the examples. So we're going to use the examples in the book. So one of the examples are the golf balls. Just because if you hit the golf ball faster, so faster club head speed, does it cause the golf ball to travel fast or travel longer for a longer distance? So something like that, yes it does. So it's causation, because you could see that when you have a faster speed, it causes the golf ball to travel a longer distance. For causation or correlation would be teenage birth rates and higher homicide. So they said that the higher teenage birth rates are, the higher homicide rate will be. But between the two, they looked at it and they find it's correlated. It's not because teens have a higher birth rate then it's more likely it will cause homicide. There are other reasons that there are homicides. So something like that, there's a lurking variable or a confounding variable. So another example is air conditioning. They think that where is it? Oh, for example, as air conditioning bills increase, so does crime rate. So do you have to turn off your air conditioner just so crime rates will decrease? Answer is no. There's another lurking variable, which is, in this case, the lurking variable is air temperature. As air temperature rises, both air conditioning bills and crime rates rise. So we're going to look at this big example here about lurking variables in bone mineral density study. So what they said is, the more you consume, does the consumption of cola, will it be associated, or will be associated with lower bone mineral density in women? So they made a correlation between the two per week, and it is negative 0.806. So they said it's a negative correlation between the two. So when they came casualty, we must collect the data, and they did so right here is the graph that they did. So you could see it's a negative correlation. Positive would go it would increase. So right now it is a negative correlation. When they identified the number of lurking variables that could confound the results. So when they thought of everything that could possibly confound it, they found it could be age, body mass index, height, smoking. So they could say it is associated, but they can't say it causes. So they could say that cola consumption is associated with lower bone mineral density because of possible lurking variables or confounding variables. They never stated that increased cola consumption causes lower bone mineral density. Another would be sweater weather. Weather. Oh my goodness. Winter
weather.
Yeah, thank you. Like sweaters. Just because people use, or just because more people start to use sweaters doesn't mean it will cause more colds. A confounding variable would be winter. Because it gets colder, the more people will wear sweaters. Because it gets colder, it is more likely that people will get colds. So that's between the two of causation and correlation.